Hi everybody, in this session I would like to teach about digital electronics. This digital electronics is a branch of electronics which deals with the generation, processing and storage of digital signals is said to be nothing but digital electronics. Digital electronics is a branch of electronics which deals with the generation, processing and storage of digital signals, and storage of digital signals is nothing but digital electronics. That helps to analyze or to analysis and to construct digital systems. This helps to analysis and construct and design, and also design digital systems. So, any information that can be transmitted through space, which is nothing but said to be a signal. Any information that can be transmitted through space is said to be a signal. Here these signals are of two types. We know already which is about normal electrical signals, nothing but electrical signals that are said to be analog signals, These analog signals are nothing but electrical signals. These analog signals are continuous signals. If you draw like this, here these analog signals are nothing but continuous signals and they vary with respect to time, then the signals are known as analog signals. We already learned about these analog signals. So, but we have a different signals which is nothing but they are confined to limited number of discrete levels. The signals are said to be nothing but digital signals. So, here the digital signals, the signal values are nothing but in discrete manner like this. Here they are discrete of confined number of levels. Here this state is said to be low, nothing but off, and this is said to be high, on. So, in digital signals are nothing but voltage and current. These signals are in discrete levels of moving. So, here this state is said to be low, off state, and this state is said to be high, on state. This can be explained with the help of 0, 1. 0 means which is in a low state and nothing but off state, and 1 means which is nothing but in a high state, nothing but in on state. This can be explained by George Boole with the help of Boolean algebra. This digital electronics was first invented by the scientist George Boole with the help of Boolean algebra. He introduced digital electronics with the help of Boolean algebra. So, in Boolean algebra we have only two numbers, nothing but 0 and 1. 0 means the number which is in low logic state, and 1 means the number which is in high logic state. These two numbers can only used in our Boolean algebra, which is different from our ordinary algebra. In our ordinary algebra, if we add the number 1 plus 1, we have 2, but in Boolean algebra, if we add 1 plus 1, we have 1 only. So, this was invented by George Boole, hence this algebra is said to be Boolean algebra. This Boolean algebra can only used in explaining this digital electronics. So, here the considering the signals are processed with the help of low off state and high on state, nothing but the signal is discreted, confined to nothing but this analog signal is confined to small parts, nothing but here 0, 1 are said to be bits. This 0, 1 are nothing but said to be bits. By these bits the information of signal can be carried out throughout the whatever we reach the signaling process. Here in this way the signals are transmitted, hence these type of signals are used this digital electronics. So, this digital electronics was invented by the scientist George Woolley. Here the signals are said to be nothing but digital signals. So, to explaining this we have with the help of a base here 0, 1, these numbers are said to be binary numbers. We know already decimal numbers. What are decimal numbers? 1, 2, 3 up to 9. These numbers are said to be nothing but decimal numbers. How can we say these numbers are binary numbers and these numbers are decimal numbers? By using here the number itself is present, we have given as 18 to the base 10. So, this confine the system which is said to by the given base is said to be base of this number, which is said to be in decimal system. The number is said to be in decimal system. By observing the base of the given number, we are saying that this is decimal system the number is in. If we have the number is 10 and 10 with base 2, then the number system which is in a binary, nothing but a binary system. And also if we have the number which is nothing but 72 to base 8, then the system which is in octal system, we have to convert in octal system. In the base which the present value, we can understand that the number given is decimal system, binary system or octal system. We have another one, nothing but if you have the number 13 itself, the base 16, we can say it as hexadecimal system, hexadecimal system. So, on the basis of the number given on the base, we have confined that which number we have to given here. So, we have in our syllabus the decimal number system and a binary number system. So, to convert a binary number into decimal number and a decimal number into binary number are contained in our syllabus. So, we go for the conversion of decimal to binary numbers and binary to decimal numbers. First we go for decimal system to decimal number to binary number, decimal to binary number. So, for this we have considered a decimal number. For example, if we consider 11 with base 10, it means this is a decimal number. To convert this 11 into binary number, we use to this 11 is divided throughout with 2. Whenever the number we have the quotient which is always less than 2, we divide throughout this 2. So, we divide this 11 with 2, then we have 5 and we have remainder as 1. And with 2, this can be divided with 5, we have 2 and remainder as 1. And also here divide with 2, we have the remainder as 1, 0. So, the result of this decimal to binary number system, we can write from bottom to top itself. Then we can write 11 to the base 10, we have as the binary number which is obtained as 1011. To the base 2, here we obtain the result as in binary numbers, then we have 11 base 10. So, the equivalent of decimal 11 which is in binary as 1011. So, in the similar manner we can understand, we can convert another number if we consider 24. So, then it also divide with throughout 2. So, we have as 1, and 12. Then our remainder is nothing but 0. Then also it this 12 is less than this 12 is greater than 2. Then another we divide this with 2. Then we have 6 with your remainder is 0, and also this 6 is greater than 2 and we divide with 2. So 3 with remainder 0, and this 3 is also greater than 2, and so we divide again with this 2. Then we have with remainder 1. Then we can write the result for this decimal to binary system as from bottom to top. So the binary equivalent of this decimal number 24 to the base 10, which is nothing but 11000 to the base 2. So in this the decimal number given we convert to binary number. If in case there is a fraction is present with this decimal number, so we observe that type of conversion. For this we considering the fraction number, which is nothing but 0. Some 125. So this is the fraction part of we know observing 0.125 number with base 10 means this is a decimal number with a fraction part 0.125. How much the binary number? Then here in this case, if the fraction is present, then we multiply with 2. Without a fraction part, we divide with 2. So we want to convert it into binary number system. So for we divide with 2. Here we want to convert this fraction part into binary number. So we take this 0.25 number and it is multiplying with the 2. Then we have the value as 1 and with 2 to 4, 5 and with 2 itself 0 point. So here the remainder is nothing but 0, and take this 0.250 remainder and it again multiplying with 2. Here the number itself multiplied with 0 and 0, 2 to 4, 5. So here the remainder is again 0. If we take this 0.500 and multiply with 2, then we have 0, 0, here is also 0. Here we write it 0, here the remainder is 1. So until the process stops, whenever the final result is obtained this way 0, 0, 0, then the process is stopped. Without fraction part, we can write the result as from bottom to top. So in this case we write the result from top to bottom. So this is said to be most significant bit and this is said to be least significant bit, and the result is for this 0.125, which is nothing but 0, 0, 1 with the base 2. This is the fraction part, hence we can write it before. So if we consider 24 and we get 24 value and adding this with in this way. This is about decimal to binary number conversion. So this is a conversion for decimal to binary numbers in a fraction part. If we have fraction part, then we take the fraction part and it multiplying with 2. Throughout we have the values of zeros. So whenever it is the process is repeated, then we doing 3-4 steps and stop it, and we can maintain the result, which is nothing but from top to bottom as the most significant bit and the least significant bit as 0 point something in this manner. Okay, I hope you are following. We go for next, which is conversion of binary to decimal numbers. Binary to decimal number system. So it is easiest than the binary number to decimal number is easiest to than decimal to binary conversion. Here for example we consider 110011 as it is nothing but a binary number. We are observing this 110011 as a binary number and the base is itself 2, it means a binary number. So then we want to convert into decimal number. How much? The decimal number we have here. So here we take this binary number and it is the process nothing but which is multiplied with 2 power 0 and 2 power 1 with the and 2 power square and 2 power 3 in this manner from right to left. Then we have adding the process 11 into 2 power, sorry here 1 into 2 power 0 plus 1 into 2 power 1 and plus 0 into 2 square plus 0 into 2 cube plus 1 into 2 power 4 plus 1 into 2 power 5. In this manner we can write and add them. These results we get the binary equivalent of decimal number. So 2 power 0 means here we start from right itself. 2 power 0 means 1. So 1 into 1 it means the number is nothing but 1 plus 2 power 1 2 nothing but 2 into 1 2 plus here is 0, then we have the value as 2 square 4 but 0 itself, then the value is 0 plus 2 cube here also the value as 0, 2 power 4 which means 16 plus 2 power 5 means we know 32. By adding these values we have the number value itself which is nothing but here 2 plus 1 3, 3 plus 16 which is nothing but 19, here 19 plus 32 the value itself which is nothing but 51. So the result of 110011 binary number, the equivalent decimal number which is nothing but 51. So we can write the result, final result as 110011 to the base 2. The equivalent decimal number is which is nothing but 51. This is the result for this manner. If we consider it as only binary, there is no fraction part. If it has a fraction part, then what can we do? So here in this manner we can multiply it with from right to left. So if the fraction part is present, then we can use 2 power 0, 2 power minus 1 and 2 power minus 2 and adding them itself from left to right. So if we take this this value again 110011 as fraction part, as a fraction part. So we can take it as 0.110011 base 2. How much the decimal fraction part? Here for this we doing multiplying with 2 power 0. Here 2 power 0 is not considered in the decimal part, we considered it as 1 into 2 power minus 1 plus 1 into 2 power minus 2 and plus 0 into 2 power minus 3 plus here 1 and we considered as 0 into 2 power minus 4 plus 1 into 2 power minus 5 plus 1 into 2 power minus 6. So here nothing but 1 2 power minus 1 into 2 power minus 1, it means 1 by 2 fraction part. This is 1 by 4 which is nothing but 0 plus which is nothing but also 0 plus 2 power minus 1 by 5 mean 2 power minus 1 by 16 minus 1 by 32 and itself 0101 to the base 2. This is the binary number, then we convert into equivalent decimal number. So from the conversion of binary number into decimal number, we take this number 1 into 2 power 0 ascending powers of 2. So 0 into 2 power 1 plus 1 into 2 power square plus 0 into 2 cube plus 1 into 2 power 4. Then we have the number first 1 into 2 power 0 and 0 into 2 power 1 plus 1 into 2 square plus 0 into 2 cube plus 1 into 2 power 4. So, the ascending powers of 2 from right to left and adding them. So, we have 2 power 4 which is nothing but then we can write from this right side only. So, 2 power 0. So, 1 into 2 power 0 means 1 plus 0 into 2 power 1 2 plus 1 into this 2 square 4 plus 0 into 2 cube 8 plus 1 into 2 power 4 nothing but 16. Then we have answer as 16 plus 0 plus 1 into 4 4 plus 0 plus 1. Then we have the result as 21. The result as 21. So, the equivalent number of 10101 binary number nothing but base 10. This is the equivalent decimal number for binary numbers. So, if we are doing the process whether we can check it, then we can convert this decimal number into binary number. Take this decimal number 21 and divide with 2, then we have the result as 2. So, divide with this 2, then we have 1 time and 10 20, it means the remainder as 1 and we again divide with 2 5 times with the remainder 0 and again divide with 2 times with the remainder 1 and again divide with this with nothing but 0 with the remainder of nothing but 1 time, this 2 in 1 time with the remainder of 0. So, the result is from bottom to top. So, the answer is nothing but 10101. So, we got the result. So, in this manner we can check also. So, here we convert this binary number into decimal number. So, we doing another problem. So, for this we considering a binary number, another binary number and doing the same process as another example. So, we consider a binary number nothing but take this 1111 and 010 as a binary number. So, find out the equivalent decimal number how much. This is our problem. So, for solving this, so we follow the rule nothing but here from right side to left ascending powers of 2 multiplying the every digit here and then add them. So, 0 into here 2 power 0 plus 1 into 2 power 1 plus 0 into plus 0 into 2 square plus 1 into 2 cube plus 1 into 2 power 4. So, we have the result as 0 into 2 power 0 1 plus 1 into 2 plus 0 into 4 plus 1 into 2 cube nothing but 8 plus 1 into 2 power 4 nothing but 16. So, we have 16 plus 8 plus 0 plus 2 plus 0. So, 16 plus 10 nothing but 36. The equivalent number for this binary number which is nothing but 10010 base 2 which is equivalent to the decimal number equivalent as here this is 10 plus 26. The result is 26. Equivalent number for this as 26 is the result. Okay. This is to convert a binary number into a decimal number. So, if we have any fraction in the binary number to convert into a decimal number, then we can follow. So, here also multiply each digit with powers of 2, but here the fraction of powers nothing but here to convert a fraction part is given like this manner 0.101 as a binary number in the decimal part here. To convert into a equivalent decimal number how much? So, here this binary number is multiplied with fraction of 2 power minus 1, 2 power minus 2, 2 power minus 3 and so on, and I add them from here left to right, from left to right. So, we are doing a problem, then we have understanding this one. So, here take this 2 power minus 1, 2 power minus 2, 2 power minus 3 fraction part and multiply with each digit and add them from left to right here. So, here we take this 0 point fraction part as 1 into 2 power minus 1 plus here we are doing from left side to right side. In the decimal part no fraction is present, we are doing from right to left. If there is a fraction part then we are doing the process of fraction of 2 powers ascending in manner of left to right itself. 0 into 2 power minus 2 plus 1 into 2 power minus 3. We know 2 power minus 1 means half. 1 into half plus 0 into 1 by 4 plus 1 into 1 by 8. It means we have 1 by 2 plus 0 plus 1 by 8. So, we have the value of 8, nothing but here 2, here 4 plus fraction part as 4 plus 1. So, nothing but 5 by 8. It means the fraction part of 5 by 8 is nothing but 0.625. You can do it, the divide 8 with 5, then we have the value as 0.625. Here in this manner, if the fraction part is given here, then we can multiply with fraction powers of 2 and from left side to right side and add them, then we have the result as nothing but in decimal number. So, here the equivalent value of 0.101 to the base 2 is equivalent to nothing but 0.625 to the base 10 is the answer. Here we must represent base value as 2, then it is only we can understand the binary number, and base value as 10, then we can understand the binary number, the number which is given as in decimal system. So, must write this base values. So, this is the process to convert a binary number into a decimal number in the fraction, without fraction and with fraction. If we have considered two parts in this binary number conversion from decimal, which is nothing but 101.101 to the base 2, convert into a equivalent decimal system, then we are doing the process of here first we consider the fraction before part. It means point, decimal point before part here binary number. So, binary part before it, then we can take this number 10101 to the base 2 first. So, the process we consider from right side to left, ascending powers of 2, multiplying the digit itself and add them. So, 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 square plus 0 into 2 cube, and also we have 1 into 2 power 4, the number is 1. So, 1 into 2 power 0 plus 0 into 2 power 1 and 1 into 2 square plus 0 into 2 cube plus 1 into 2 power 4. We know, so 1 into 2 power 0 itself 1 into 1. We have here 0 into 2 power 1 2 itself plus 1 into 2 power 4 itself plus 0 into 8 plus 16, 1 into 16. So, we have 16 plus 2 power 4, sorry here 4 the term which is nothing but 4 plus 1, and then we have the result as 20 plus 1 nothing but 21. So, the equivalent part for this before the fraction part is 21. So, we already calculate 101 fraction part point which is nothing but 0.625. So, finally, the result for this binary number 10101.101 to the base 2, which is nothing but the result is we have got 21.625 to the base 10 is the result for equivalent decimal number for this binary number. I hope you are following the conversion of binary into decimal and decimal to binary. To convert a decimal number into binary number, we can divide with 2 throughout if there is no fraction. If the fraction is present, then we can multiply with 2 until the values of remainders as quotients values as zeros. And to convert a binary number into decimal number, so without fraction part, we can multiply with the powers of 2 in the ascending manner and add them from right side to left side. So if there is fraction part is given, so then we can also by taking the fraction part of powers of 2 and add them from left to here, left to right, fraction part is taken and add them. We have the process to convert a binary fraction part into a decimal number. I hope you are following these two processes, and these two processes are important to our examinations. Okay, thank you.